Hi guys, in this video we'll be looking at how to calculate a parallel circuit. So as we can see here, we have three resistors connected in parallel. So the first thing that we will do is find the total resistance of the circuit. So because I have three resistors in parallel, I will do them two at a time. So the first two resistors that I'm going to concentrate on will be R3 and R2, and I'm going to get that will be R parallel 1 is equals to R3 multiplied by R2 over R3 plus R2, which will give me 4 multiplied by 5 over 4 plus 5, which will give me a resistance for those two resistors of 2.222 ohms, which means those two resistors now becomes R parallel 1. So next I'm going to get the total resistance because now I'm going to have R parallel in parallel with R1, and that is going to be my total resistance of the circuit. And now I can say that the total resistance for the circuit is going to be my R total is equals to my R parallel 1 multiplied by R1 over R parallel 1 plus R1, which will give me 2.222 multiplied by 10 over 2.222 plus 10, which will give me a total resistance for the circuit of 1.818 ohms. Next, we will calculate what is the total current flowing in the circuit. So the total current flowing in the circuit is going to be my I total, which is equals to my V total divided by my total resistance, which I've just calculated, and that is going to be 9. 9 is my total voltage of the circuit divided by 1.818, and that's going to give me a total current flowing in the circuit of 4.95 amps. Now guys, the next thing that I'm going to calculate is I'm going to calculate what is the voltage drop over these resistors. Now very important, the voltage drop over these resistors will be equal to my total voltage in the circuit. If we can still remember what we've learned from series circuit, is that in a series circuit we have voltage drops over that resistors, which means the sum of the voltage drops must be equal to the total voltage in a series circuit, and my current in that circuit stays the same throughout. While here in a parallel circuit, as I've said, my voltage will be the same over that resistor, and that resistor, and my current in the circuit will split into the branches. So that means that my V1 is equals to V2 is equals to V3, which is equals to my total voltage of 9 volt for this specific circuit. Next, we will calculate what is the current flowing through each branch, which means through R1, what is the current flowing through R2, and what is the current flowing through my third resistor. So my first current I1 is going to be equals to my total voltage divided by R1, which is 9 divided by 10, which will give me a current of 0.9 amps flowing in that branch through my R1 resistor. My current I2 will then be V total divided by R2, which is 9 divided by 5, which will give me a current flow of 1.8 amps flowing through that resistor. And then my last current that we need to calculate, that will be I3, which is also V total divided by R3, which is 9 divided by 4, which will give me a current flow of 2.25 amps flowing through that resistor. So now that I have all my currents, there I have my I total, that is the total current flowing in the circuit. There I have my I1 flowing through that branch. I have I2 and I have I3. I can now use Kirchhoff's current law to see if I actually worked correctly. And Kirchhoff's current law says that my I total is equals to I1 plus I2 plus I3, which will give me a total value of 4.95 amps for this specific circuit. So if you add that up, if you're working with a circuit like this and you add up your currents which you have calculated in a parallel circuit, you need to get to the total current. Then only you will know that you have worked correctly. Next, we will calculate what is the power used by that specific resistor there. So the power used by a resistor R2 is going to be PR2 is equals to I squared multiplied by R, which is going to give me 1.8 squared multiplied by 5, which is going to give me a total power of 16.2 watts, which is used by resistor R2. Now guys, there are three power formulas that you can make use of. The one that I use was this one, which says P is equals to I squared multiplied by R. The other two is P is equals to I times V and P is equals to V squared divided by R. Now you can use any one of these power formulas provided that you have all of the information of what you want to calculate. Here I have the current through that branch. I have the resistance of that specific resistor, and I also have the voltage drop over that resistor, which means I can use any one of these power formulas. So guys, I have come to the end of the video. Subscribe to the channel and hit the notification bell so that you can be notified when I upload a new video.